with us now to the terrestrial planet of Mercury. Welcome, digital friends. I'm Colleen Parrott, the social media and public relations coordinator here at the Space Foundation, and I'm with Kara Berwick, one of our Space Foundation space education specialists. Today, we're going to talk to you about the closest planet to the sun, Mercury. So we've got some fun facts, a little bit of history, and some questions sent in by you. We're going to answer all of those. So Kara, can you tell us a little bit about what we're seeing here?
Sure. This is our planet Mercury, and I say our very loosely, but it is Mercury, and it is the closest planet to the sun, and it is a rather small planet. If you don't include Pluto, which lots of people do, but scientists don't right now, then Mercury is the smallest planet. It is also about, if you compare, if you had a baseball, that would be Earth, and if you had a golf ball, that would be Mercury. So Earth and Mercury.
Pretty big difference.
Yes, so they're very tiny. The good thing is they're both rocks, which we like to call our terrestrial planets. So our first four planets are all terrestrial planets because they're all rocks.
That's pretty cool. I never knew that's what that word meant.
I know. You think about ET, extraterrestrial, it just means rock.
Does that mean ET was a rock?
Well, no.
Okay.
He may have been from a rocky planet.
Okay.
I'm going to have to go back and watch the movie now to see why did they call him ET. So, yeah. So Mercury also, I'm going to put up a new picture for you. Mercury, you can see, has a lot of craters. So when the solar system was first forming, the sun's gravity was pulling in a whole bunch of space rocks, or meteors and asteroids, and so they just were bombarding Mercury. And so you can see there are tons and tons of craters. One of my personal favorites is, it's a good thing I can't do this with the real Mercury.
Would that go off the Earth's gravitational spin or anything if Mercury could turn like this?
That I don't know. Okay, so down here, more kind of in the southern hemisphere, we have what's called the Calorus Basin. And this particular rock came and hit and created this enormous crater. And it actually looks like little spider legs coming out because it had such an enormous impact. And the impact also created on the reverse side of the planet some hills and mountains. So it hit so hard that it created an enormous crater on one side and popped some mountains out on the other side. So I don't know about you, but I am thankful I was not on Mercury during the forming of the solar system, because you probably would have been smashed by space rocks.
That sounds pretty horrible.
Yes, yes, but it makes for an interesting surface of Mercury because it has so many craters, and part of the reason it is not protected is it has no atmosphere. So there's nothing to keep the rocks and the meteors from coming and bombarding the surface. There's no kind of protective layer, which we have on Earth, again, thank goodness. So it's almost like a blanket wrapped around Earth, and Mercury just doesn't have that. So it's just going to get creamed with any sort of space junk that's flying through.
That sounds pretty horrible.
Yes, yes. It also makes the temperatures really extreme. So again, there's kind of nothing to keep the heat in during the day, and so at night the temperatures are well below 0 Fahrenheit. So we're talking negative 270 degrees Fahrenheit on average. That's the average temperature. So it's extremely cold. But then on the flip side, when it's daytime, it's extremely hot. So we're talking 800 degrees Fahrenheit. So hotter than even your oven can get, and that's just day and night. So the temperatures can vary quite a bit.
And you might remember last week when we talked about Venus, that Venus is not the closest planet, but it can actually get hotter because of its atmosphere. So it's really weird to see that that atmosphere makes such a difference that it can get absolutely that cold there, and I do not like the cold. So.
No, there aren't enough jackets and gloves in the world for keeping negative 270 degrees Fahrenheit out.
That's good to know.
Yes, yes. You also would melt in the heat, so it's not a hospitable planet by any stretch of the imagination. So, yeah.
It's making me cold thinking about it.
Yeah, now, I mean, you could say that it might be nice because the year goes by extremely extremely fast. Mercury actually orbits around the sun in 88 Earth days. So in about 3 months, a little less than 3 months, Mercury has created a complete orbit of the sun. So hence its name. So Mercury is a Roman god. He's the Roman messenger god, but he was very speedy. And so that is why Mercury got its name, because it's one of the fastest orbits.
That's really awesome.
Yeah.
And a fun fact about Mercury is I actually know Mercury better by the Greek god's name, which is Hermes. And I think a lot of people remember him. He has the wings on his feet. So that has always stood out to me to remember, oh, well, that's the fast one. He flies.
Exactly. He's the speediest. So, but it has a very speedy year, but its days actually really long.
Oh.
And so
Or Mondays, huh?
Yeah, Mercury has Mondays for a really long time. So it actually revolves in 175 Earth days.
Wow.
So it takes longer to revolve around than it does to orbit around the sun. So one day actually takes longer than 1 year on Mercury.
Now, we were talking about Venus last week and how the sun rises twice, but you were telling me the other day that the sun doesn't actually always set.
Right, so
on
it kind of rises over the horizon and then dips back down and then rises for the full day and then dips back down. So it kind of does this pebble jump when it's rising and setting. But again, it takes 175 Earth days to get through 1 day. So you're looking at a really long time that the sun is up, which again, that's, your 800-degree day is a really long time.
Really, really long time. Well, what's the gravity like on Mercury?
It's smaller, so it's going to be less than Earth, although Mercury is one of the most dense planets, so per area it's more dense than anything else, but the gravity's going to be a little less.
So if you weighed, let's say, 140 pounds, do you know about how much you would weigh on Mercury?
Ooh, good question. I don't, but I do know your mass would be the same.
Well, that's good to know. I'll make sure that doesn't change.
Yeah.
Well, it sounds like it's a really, really desolate place, not somewhere that I would ever want to go to. When was it first discovered? Do we know kind of approximately if the Romans named it? Obviously, that was a long time ago.
Yeah, it definitely was a long time ago. They were observing most of the terrestrial planets in the sky well before anything we've recorded technically in data. So 265 BC is when it's kind of recorded that someone saw it. So they can't really say who saw it first or which group of people saw it first, because we don't have enough accurate records that far back. But that tells you, a long time ago people were actually observing things in the sky. So you can see a lot of our terrestrial planets because they have a little bit of sparkle to them or sheen. So if you're looking up at the night sky, you see stars, they of course sparkle, but the planets actually have more of a shine to them. So if you see something that's really, really bright in the sky, you're most likely looking at a planet.
That is wonderful information, because I have a friend that she keeps seeing something in her window, and she keeps texting me pictures, and she's like, what is this? And I was like, I don't know. And at first I thought it was Venus, and then yesterday she sent me 2 of them, and she's like, there's 2. I'm not quite sure at the moment. So.
Yes. You can get the apps that if you hold your phone up to the sky, it can show you, but when you're seeing them together, you're more than likely seeing Mars and Venus together.
Oh, okay. Well, that's good to know. I'll have to let her know that. So we talked about how it's named most likely for a Roman god. What about the craters? Because everything in the solar system seems to get named from something or another. So how do they decide on the names of the craters, like that giant one you're telling us about?
Well, that's one of the things I really love about space is they kind of pick themes for their names. And so the craters are your famous artists and your famous writers and composers. And so they kind of made Mercury this famous crater. And so I think it's great, that people get to choose, like, let's make them artists on Mercury. So who knows? I don't know how they choose who gets the biggest. Are they the most popular or the least well-liked? I don't know. So
then it all gets voted on.
Yeah, exactly.
So you mentioned that we didn't really know a lot about it. How many missions have you been to Mercury?
It's pretty difficult to send missions to Mercury just because of the proximity to the sun. So we've sent two. In the 1970s, we sent Mariner 10, and so that was just a flyby. It just flew by Mercury, took some pictures, and sent some data back to us. But it's not going to get a whole lot unless it's able to be caught in Mercury's gravity and kind of orbit around Mercury itself. So unfortunately, Messenger just flew by. We did get some good pictures, a lot more information than we'd ever had from telescopes, so that's pretty exciting. So that kind of bumped things up. But then we sent Messenger, and it took 6.5 years to arrive, and it actually, I don't know, it's kind of bizarre. You spend so much time building something, and then you put it in space, and you have to wait 6.5 years before it does its job.
And then getting the data back takes
Right.
forever.
Yeah, so then I feel like anytime we send something into space, it's kind of a waiting game, and I can't imagine waiting 6.5 years for something you've been working on forever. So
That will teach you patience.
yes,
Right there.
go into space if you want patience. So yeah, but the good thing about Messenger is it was actually able to orbit, so we were able to get more pictures, which is why we can put things like this on our sphere, where you can see all of Mercury, not just portions of it.
That is very, very awesome. So you just mentioned we can see all sides of it, and so we were able to get that when they orbited.
Yeah, so essentially what we've done on the sphere is we've stitched together a whole series of pictures. So it's, well, the picture you see is almost a patchwork quilt of pictures that the Messenger has taken.
That's a neat way to think about it.
Yeah.
So, and I've heard that there's actually another mission going back. Have you heard about that at all?
Ooh, that one I'm not as familiar with. So, I mean, Mercury is definitely one we want to study because as our sun grows bigger in billions of years, but as it grows bigger, what happened on Mercury could possibly happen on Earth. So it's good to study all of the planets just because if we want to save ours and keep ours to be habitable, we got to know what happened to the other ones. So
That would be a good thing to know. And from what I was reading, that it's the European Space Agency and then JAXA, who's the Japanese Space Agency. And it was supposed to be sent before, and again, like we said, you have to have patience with space. So launched last year, and now it's going to go next year. I've heard the same thing. It's going to take a long time to get there. So it'll be some time before we get any of that data back. So it'll be interesting to see. So we have a few questions from our Facebook viewers. So Trevor from Colorado Springs wants to know what is on Mercury.
Well, we kind of talked about the craters, and that's pretty much what's on Mercury. It's a rock with a whole bunch of craters. They do believe it has a core and a crust as well, so a core, mantle, crust, just like Earth does. So they believe it has an iron core, and then the mantle, and then the outer crust that has the rocks and the iron as well.
So if you were to find an iron rock outside, it would be just like finding a rock. Is that pretty
Kind of,
similar?
yeah. I mean, there's only so many compositions of elements that you can create and consider it a rock. So yeah, I don't know where we might have rocks that would be similar to Mercury. So that would be kind of interesting to
That
know.
would be interesting to see. So
Travel
I guess
to
we'll find
something.
out in a few years.
Yeah, there you go.
And we have a few other questions. Sherry sent a couple. One, you kind of talked about the minerals, that she wanted to know what minerals in the rocks were composed of. But she was curious, how did it form, and do we have any idea how old it is?
That's a really good question. I think a lot of scientists are always looking into that and kind of guessing. Educated guesses, obviously, but a star has intense gravity. So when a star is formed, it kind of pulls things in. So that is how they believe most solar systems are formed, is that star is formed, it creates that intense gravity, and then it pulls things in from outer space, which is part of the reason Mercury has so many craters, is because so much was being pulled in. Mercury was strong enough to kind of sit in its spot, but it got hit by everything else that was super small and on its way to the sun.
So it kind of protected the sun in a way, I guess.
Yeah,
A little shield.
spot, yeah.
And then finally, we've got Dean from North Carolina, and he wants to know if he can see Mercury from his house.
Well, it depends on the time of year and where Mercury is in its orbit and where Earth is in its orbit. So So the best thing to do would be to kind of look up when Mercury's going to be in your area above your night sky. Because what's happening in India or in your European areas is not going to be the same as what's happening in Nebraska. So it's kind of like constellations. They're up for seasons and down for seasons. So.
Well, an interesting part with that is there's going to be a lunar eclipse, and it's not a full lunar eclipse tonight, but it's only going to be viewable in part of the world. Part of the world won't even get a chance to see it. And same with, we have a full solar eclipse coming later this year, and some people are going to get to see it, and it's kind of a small path of people who are going to get to see it. And here in Colorado, I don't think we're going to see all of it. We get a good chunk, but not quite all of it. So.
Yeah, we got to head a little bit north to be in the right pathway.
So that's going to be really, really awesome for them. And what I heard was that we won't actually get a really good chance of seeing Mercury until 2019. So that's, again, we're going to have to wait a little bit to know any more about Mercury here because it's just tiny and it's so far away and kind of does its own thing.
Which makes you pretty amazed with the people who studied it in the past when you think about the equipment they had and how long they had to wait for things and their willingness to study a planet that they could only see, every couple decades. So.
Yeah, I definitely more power to them because that had to have been a lot to have to deal with. But we want to thank all of our viewers who sent in questions last week. We're going to be back in 2 weeks. We're talking about the red planet Mars, and Mars has been a really hot topic lately, so I know that some of you out there have some wonderful questions. So please go ahead and send those on in. Just leave them in the comment section, and we